Hello everyone, welcome to IMS Gate Academy. Here we are going to start Gate 25 EE Gate exam analysis as well as the detailed solution. So my dear student, just now exam completed and these are the pattern of question that has been asked MCQ 34, NAT 26 and MSQ 5. Recently I made a short video on the same. Now guys, I have some questions, some memory based question. So we are going to solve here some memory based questions here. You can also confirm the data if you have attempted the Gate EE exam, Gate 25 exam. So I have first question from digital. I have the first question from digital subject. Okay. So I am writing in short form. Now digital circuits first question. Let me take different color of pen here. Okay. So my first question. So F equal to given to you guys U bar plus V bar plus W bar plus X bar. So guys, this is definitely POS form is given to you. As I told you in the classes guys, sometimes students prefer SOP form, but you should practice this POS form as well. Okay. So however, the question is very easy. I know many students already if you attempted the GATE exam, many of you attempted it correctly. So let's see. So U bar, V bar, W bar, NX and dot here one more U bar plus V plus W bar plus X bar. And here we have what guys? U bar plus V plus W bar and plus X. So this is the question given to you and you have some options as well here, 4 options, and options are given. That what is the minimized expression? Minimized expression is represented by which option? So here OR gate is given to you and here U and W. Option number B is, we have option number B like this. This is the option number B and we have here V and X. Option number C, we have here NOT gate and we have one more NOT gate here, and after that again OR gate. So it is a bubbled OR gate, so it is working as a NAND gate when you will open this. So let's see how it will work. So now here we have, we'll check the output later, but here this is the F, okay. And what are the input values? U, W, and here is V and X, okay. Now guys, I will solve the solution part. I will do in this part, okay. So let me make some space here, okay. So this part will do the solution part, okay guys. Now, so first of all you should tell me, student, what you need to write. Can you write in this sigma m or pi m form? Of course in the SOP we will prefer sigma m and in the POS form we prefer pi m, yes or no? Very good. So pi m, so I am writing here F in terms of pi because it is given in the max term or it is given in the form of POS, product of sum, okay. So do you know in the SOP we have a 0 pay bar, 1 pay no bar, but in the POS we have 1 pay bar and 0 pay no bar guys, 0 pay no bar. This is the beauty of POS expression. So this is the POS expression. So what should I write? Should I write here because of 1 pay? Here is a 1 pay bar and 0 pay no bar. 1 pay bar, it means should I write here? Is it 1, 1, 1, 1 and 1, 1, 1 is nothing but 15? Yes sir. Now next is what guys? 1, 1, 1, 0. So is it nothing but 14? Yes sir, 14. Now here 1, 0, 1, 1. 1, 0, 1, 1 is nothing but 11. Yes sir, 11. And 1, 0, 1, 0 that is nothing but 10. So 10. Now some student you can even definitely write its equivalent sigma m also, and what will come in the sigma m? So this is your pi m, and if you wish to write sigma m, then in the sigma m whatever min terms are, whatever terms are here, the remaining terms will come in the sigma m. But no need to do like that because it's an unnecessary wasting of time, because ideally you can directly make a K-map in this POS only and you should make a grouping of zeros only, yes or no? So if you will if you will make the grouping for 1 and if you will write the SOP form, definitely it is just the wasting of time. However, you can definitely do like that, but in the GATE exam, it is also important that how much time you are taking to solve the question. So, you should definitely give the preference to the POS expression only. Now, here we have UV and WX. And you all know that 0, 0, 0, 1, 1, 0, 1, 1. Here is also 0, 0, 0, 1, 1, 0, 1, 1. And numberings are just for your explanation I am writing here. 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, 14, 15. Yes. Now, because it is a POS, so I should write here 0 as 0 because POS representing max term, and the max term POS expression only used when the output is logic 0. So, output logic 0 means 10. It means 10 here, sir, 0. Then 11 again 0. Then 14, 14 0 and 15 0. So, this is the only group you need to make, and that is the only answer, guys. Of course, we have a opportunity to make a 4 variable group here, and because we should write in a POS expression, so POS expression can I write here because U 1 pe bar, so should I write U plus V bar, and here should I write U bar plus V, yes sir, and here is again W bar plus X bar because 1 pe bar, 0 pe no bar, and here is W bar plus X. So what is common in these two, guys? What is common in these two? So you can write, sir, of course W bar is common, sir, W bar is common. And here is because of POS, in between we should write plus sign. And what is the common here, guys? U bar. So you will write W bar plus U bar, W bar plus U bar. And then of course you can write as a W U. If you will apply here W U whole bar. Yes or no? So that is why I told you option number C for Chennai Super King is only correct answer for this, because here you will get U bar plus W bar. So W bar plus U bar. And bubbled OR gate will also give you the NAND gate, so you can write in the equivalent WU ka whole bar also, because when you will open it again after De Morgan, you will again get the same. So I hope many of you already attempted this question correctly. So here this is the option correct, guys. In whichever option this expression was there, that particular answer is nothing but W bar plus U bar. Okay. Again I am telling you, if you wish to write its equivalent sigma m, then whatever max terms are here, the remaining will come as a min term here. Okay. So it means 0, 1, 2, 3, 4, 5, 6, 8, 6, 8. So 0 to 9 definitely will come. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that 10, 11 here. So 12 will come here, 13 will come here, and the remaining 4 here. So remaining 12 min terms you will get. 12 min term means all min terms like this, and here also you can make 8 variable group in the SOP. In the SOP means we have to make grouping for the 1. So if you will make the group for 1 SOP, again you will get the same answer. Again you will get the same answer only. So I think, guys, this question everyone already completed now. I hope you guys completed this question. This is easy question, guys. So that is why everyone must solve this question. If you already attended our classes, and if you know the simple basic concept of digital, if you know, then it is a must solve question, and everyone should try to get positive marking for the last question. Now, one question I have from signals and system, guys. From signals and system, this is again an easy question. Examiner has asked about the power. So what is the question I am writing here? In the question it is given that x of t is equal to 1 plus is given, x of t is given as a, now x of t what given, guys? 1 plus 2 cos of 2 pi t, okay, 1 plus 2 cos 2 pi t plus 2 cos 4 pi t and plus 2 cos 6 pi t. I hope it is clear, guys. Yes. So this is the question, guys. This is the question, and what examiner asking? Examiner asking we need to evaluate this integral value, that is nothing but 1 by t. Okay. Examiner asking for this value. Find this value, that is mod of xt whole square dt. Mod of xt whole square dt. So this value we need to find. And do you know this is nothing but the power formula, guys? This is nothing but the power calculation. So examiner wants that you need to calculate power. Now do you know for a sinusoidal signal what is the power? For the sinusoidal signal, sir, whenever we have the different frequencies, for the sinusoidal signal we have this, if you know this note, that DC power is what, guys? The DC power is always A square. And what is the power of A sin omega 0 t or A cos omega 0 t plus theta? Both power is nothing but, sir, A square by 2 only. And RMS value is nothing but A by root 2. So guys, whenever the sinusoidal terms are in the addition, but the frequencies are different, then we can directly go for A square by 2 only. So you should just focus on the magnitude part. And we know that ki power calculation is independent to time shifting, time scaling, time reversal. Yes or no, guys? Amplitude reversal even. Yes or no? So all of you guys just confirm whether this data is correct or not if you attempted doubly today's paper. Now the power calculation simple formula, what you need to do directly DC. DC means A ka whole square means 1 ka whole square plus A square by 2. It means you should write here 2 ka whole square by 2. Again the amplitude is 2. So again you need to make 2 whole square by 2. And again magnitude is 2. So you have to make 2 whole square by 2. So it means when you will solve this, you will get the correct answer, guys. It is very easily you can get 1 plus 2 whole square by 2 is nothing but 2, 4 by 2, again 4 by 2 is 2, again 4 by 2 is 2. So 2 plus 2 plus 2, 6 plus 1, 7. So the final answer for this question is 7. Whether it is a NIT question or a MCQ question, you can check. Correct answer is this only. Hi Priyam, how are you, beta? Ankur sir rocks. Thank you, beta. Thank you, Priyam. Priyam, thanks a lot for always sharing your experience from the bottom of your heart. Chali. So we have one more question, beta. One more question, all of you. xt equal to, that is also from signal sense system. So I am going to solve the third question here. This question is also from signal sense system. And this is the very basic question. I think everyone easily solve this question because it is based on the first impulse properties of impulse. Father of signal. Thank you so much, Priyam, beta, for your lovely words. Thank you so much. And every student, those who attempted the GATE exam, EE exam, how was your experience, guys? You can share in your chat box also. Okay. So chaliye, now the question is, examiner asking, guys, x of t value given to you. X of t value given, what is the x of t value? Minus t square whole bracket u of t plus 4 and minus u of t minus 4. However, by observing this only, you will get the limit from minus 4 to plus 4. But examiner has, okay, so this value is given to you and otherwise 0 otherwise, okay. So this is the question given to you, guys, and examiner asking the integral value from minus infinity to infinity x of t dot del of t plus 3 dt. So this you need to find. This is the question, guys. Can you please confirm the data first? All of you just confirm the data whether this question was there or not. You can only confirm if you have attempted the paper, guys. Yes. Yes. Hindi question, sir. Yes. Easy question, very easy question, because student, this nature, it means you can say that this signal is limit from minus 4 t equal to, this signal limit from t equal to minus 4 to plus 4. Yes or no? So if you want to apply the formula here, then what you will get? You will get the formula from, because of this limit minus 4 to plus 4 and x of t value, when you will put here, because this value you will get 1 only because it is a rectangle pulse. So from this, now here student, what you will get? You will get here minus t square, you need to type just as it is this. Minus t square into this is xt value I put it, and then I need to write a del of del t plus 3 dot dt. And do you know here what is the property? I am just writing the property here, guys. The property says that if the limit is from minus a to plus a, suppose that limit is minus a to plus a, and here is x of t del of t minus t naught or t plus t naught or t minus t naught. Okay, so suppose I am taking plus because in this plus. So do you know what is the result? The result is nothing but x of this t naught, because this is t plus t naught, so minus t naught going to be replaced here. So the final answer is x of minus t naught. This property we can only apply if the location minus T naught must be between or must lie between limits between minus A to plus B plus A. So if this is minus A to plus A limit, so if del function exists between this limit, then only we can apply this property, sir. So here student del T plus 3. Del T plus 3 means the impulse location is at minus 3 actually. Del T plus 3 means location of impulse at minus 3. So minus 3 going to be shifted in place of T. So wherever is T, minus sign already outside. Now wherever is T, here is T. The T going to be replaced with minus 3, and then this nature of the signal is square, so square only. So when you will perform, minus already outside, minus 3 ka whole square is 9 only. Correct answer for this question is minus 9. So guys, can you please confirm this? Have you got this? Questions को हवा में उड़ा देंगे. शाबाश बेटा प्रियम, very nice, very nice. So if you are our classroom students, such questions definitely guys must attempt questions. You can't afford negative marking for such questions, I am telling you. Just you need to make sure that in the examination hall you not so much nervous, because if you were in the so much pressure and if you could not perform as per your efficiency, then maybe such questions also you might did wrong. But ideally I am telling you guys, frankly, this question you need to must solve. Okay, if you know signals and system basic knowledge, and if you revise thoroughly your classroom notes, then these questions definitely you must attend and you should get the positive marking for the same. Okay guys, so we have other mentors also, so they are coming here to solve some other problems. So I would like to invite JP sir here. So I would like to invite JP sir. He will solve some more questions from. So JP sir, I think many of students already shared some questions, some memory based questions. So what you think, what was the difficulty level for EC paper?
Electrical.
Electrical paper, sorry.
Yes, sir. So as of now, whatever the questions we have received from basic subjects or common subjects, we mean to say, with respect to that subjects, we got like easy questions only. But with respect to core electrical, students might have felt like moderate kind of questions.
Okay.
So Vipin sir may already attempted the GATE exam, so he will share his experience
He is on
also.
the way. He is coming very soon,
Yeah.
and he will be live also with us. So, right
with respect
now,
to as of now, whatever the questions we have received, our students are sharing, so we can consider like around moderate. Sir.
moderate. Okay.
As of
So you have some questions of network or analog?
regarding analog circuits, we have received
Please
two
solve.
memory-based questions, so I am going to solve those
Okay,
questions.
please solve.
Yeah, thank you, sir. Yeah, this is the question asked from analog circuit subject. This is the easiest question. This is a question of MCQ type. Among the 4 choices, only one option will be correct. So they have given, okay, so first you can write down the question, identify the given circuit. Here input is V in, output of this op amp is V out, and here you are having one more op amp. Here positive terminal is connected like this, and negative terminal is connected to output of this op amp. And then here they have made the connection like this. Okay, so this is circuit diagram given. Here one op amp is there, and output of this one connected here positive terminal, then negative terminal is connected here. This is circuit they have given, and here you have to identify the given circuit. So for this question you are having 4 choices. Among the 4 you have to choose the correct option. Option A, summing amplifier. Option B, difference amplifier. Option C, logarithmic amplifier, or in short I am writing log amplifier. And option D, you are having buffer. I hope all of you solve this question easily, right? Yeah. So just observe this particular circuit. For overall circuit, if you observe, you are having one input and one output, correct? For overall circuit, you are having one input and one output. So just by observation of this overall circuit, whatever you are having 2 op amps, broadly if you consider like one block diagram, okay, for overall circuit, you are having one output, one input. Okay, with the help of that observation, here summing amplifier we can eliminate, difference amplifier also we can eliminate. Yes or no? Because if you want to perform either addition operation or subtraction operation, definitely you can have either 2 inputs or more than that, correct? So among whatever the inputs you are having, if you are performing among all the inputs, if you are performing addition, it is called summing. And if you are having 2 inputs, then we can perform subtraction, then accordingly difference amplifier. But if you are having either 3 inputs or more than that, according to the requirement, you can perform like among few inputs addition, among few like remaining thing subtraction, etc. Like that you can get whatever the equation you want to get, like in terms of addition, subtraction, etc. Okay, so since in this particular circuit diagram, broadly you're having one input, one output, with the help of that, we can eliminate option A and option B. Now coming to the logarithmic amplifier, so you will be having in the circuit, diode also should be there. So in this circuit, there is no diode, so we can eliminate option C also. So the leftover choice, option D. So without using pen and paper, just by observing the circuit, you can choose buffer. Okay, just by observation, you can choose buffer. But even if you want to verify, okay, even if you are having slight confusion, you can verify, definitely you will be getting buffer. See, yesterday also we have discussed one instrumentation question that we have received from our students based on their memory. Okay, we have solved one op-amp question. There also we have discussed regarding virtual short concept. Whoever, like any student, whoever preparing for the GATE exam, definitely regarding each and every subject by this time might be strong on the basics. Even whoever watched yesterday's session, definitely with the help of that logic, you people could have solved this question correctly also, right? So virtual short concept means physically there is no short. Physically with the help of wire there is no short, but virtually short is happening. See, it is very simple. Just observe here for this op amp. Okay, you're having 2 inputs. One is positive terminal, another one is negative terminal. Whatever the voltage you're having at positive terminal, the same voltage you are getting at the negative terminal or inverting terminal. Yes or no? That is the first observation, correct? So here, whatever the voltage you're having, exactly same voltage you're getting. Okay, now that one here also, same thing, correct? Okay, now just observe. See, whatever the concept currently we have discussed, exactly same. Whatever the voltage you're having at the positive terminal, exactly same you're getting at the negative terminal. Okay, suppose if this voltage is 0, then accordingly here also 0. But if other than 0 or whatever the voltage here you're having, exactly same voltage you're getting. That means it is very simple. If you shorted these two, just like here, you have shorted with the wire. So exactly here short is happening, but that is not physically with the help of wire. Rather virtually it is happening. That's why we used to call it as virtual short. Okay, fine. Suppose if this voltage is ground, is 0 volt or ground, then we are calling it as virtual ground, like that. Okay, fine. whatever the logic just now here we have discussed, exactly you can apply here. Whatever the voltage that you are having at positive terminal, that positive terminal voltage is nothing but V out. Now exactly same thing you are getting at the negative terminal, correct? So that means V out. Now just observe. Here, this terminal and this terminal both are same. Just you have connected with one wire. So that means here V out equal to Vn. So whenever you are getting V out equal to Vn, so from there if you take the ratio, V out divided by Vn is nothing but 1. So whenever gain of the amplifier is 1, so that is nothing but buffer. So accordingly we can say, right? Unity gain amplifier or buffer, all are one and the same. I hope all of you attempted this question correctly. Okay, now we are going to solve one more question regarding analog circuit subject. So first I will draw the given circuit. So this question is of NIT. Yeah, in this question, they have given the circuit like this. Here 10 kilo ohm resistor, here also 10 kilo ohm. Then here once again 10 kilo ohm resistor, and then just like this op amp, exactly similar they have given minus plus polarities. Okay, and here also they have given feedback resistor as 10 kilo ohm. See, whatever the configuration here they have given, exactly same configuration. So op amp is there. For the negative terminal, the input resistance 10 kilo ohm and feedback resistance also 10 kilo ohm. Similarly here, one more op amp. For the negative terminal, input resistance is 10K, feedback resistance is 10K. Okay, and here the final output they have labeled as V0. And here in this question, the surprise is for the positive terminals of these two op amps. Okay, with respect to those two positive terminals, they have connected the input. That means for overall circuit, you are getting output here. The corresponding overall input voltage they have given between the positive terminals or non-inverting terminals of these two op amps. So here in this question, like they have put the positive polarity here and negative polarity here, and then they have mentioned VN. So this is the only twist in this particular question. Okay. Now in this particular question, what you are supposed to calculate, whatever the given circuit you are having, okay, if you consider if the given op amps are ideal, then the value of V0 by Vn, then the value of V0 by Vn will be dash. Okay, I hope many of you might have solved this question correctly and few students might have stuck in order to find out the correct answer for this question. Okay, so just observe here in this particular question. Yeah, say for example, when you don't have this one, when you don't have this circuit, okay, then with the help of only this circuit, if you observe the part of the circuit here, So this part of circuit is what? Inverting op amp. Yes or no? Inverting op amp. Similarly, if you just ignore this part of circuit, if you consider only this part of circuit, here for the inverting terminal also we are giving the input, and here for positive terminal also we are giving input, correct? So that means here we have to consider with respect to positive terminal and with respect to negative terminal according to the corresponding voltage, whereas here with respect to only positive terminal we can write down corresponding output voltage. So whenever you are getting like this lengthy question, okay, actually this is a very important note point for EC students. Whenever you are getting like cascaded form, you might have got very much familiar regarding cascaded in the signal and system and control system, right? Similarly, even with respect to digital also we have discussed a good number of questions, right? When you're having flip-flops, okay, so that time you can analyze stage by stage, okay, and then you can proceed also. Like that, even the similar concept you can apply in the op amps also in the analog circuit subject. That is the beauty of with respect to EC electrical instrumentation. Whatever the concept that you have learned in one subject, if the possibility is there, you can apply in other subject also. Definitely you can like, even though you might have thought initially that particular question is complicated or tough question, but if you are able to apply like this shortcuts, or if you are able to analyze like stage by stage, then you are getting the complete picture. So that is a way, if you can do it whenever you feel that the given question is tough, or if you are unable to get what is the clue for that particular question or how to proceed, etc. Now this, whatever the tip I have given now, at least you people, whoever going to write for EC branch, EC exam on February 15th, you people can apply these tips. Definitely you can maximize your score in the GATE exam. Okay, right. So now with this understanding, now let us, okay, for easy understanding, let us put here, say for example, even though the voltage between these two positive terminals, according to the question Vin has mentioned, for the time being, let us assume the voltage at this particular negative terminal, I am assuming as VA. Okay. Yeah. Say for example, with respect to this positive terminal voltage, I have assumed as VA. With respect to here, positive terminal voltage, I am labeling as VB. Suppose. Now forget about this part of circuit, as we have already discussed. Here, the part of the circuit here, whatever you are having, this is the inverting mode op amp. Okay, this is the inverting mode op amp, right? So with the help of this one, okay, for the timing, I am labeling here output voltage at the first stage. So I am labeling as Vout1. So Vout1 equal to, because it is the inverting mode op amp. So why we are calling it as inverting mode? Because, sorry, it is not inverting mode, it is a non-inverting mode. Because here we have given the voltage to the positive terminal or non-inverting terminal. So accordingly, the formula you are going to get 1 plus feedback resistance divided by input resistance. Here feedback resistance is 10K and input resistance also same, 10K only, right? Okay. Into input voltage. Here input voltage I have labeled as VA. So from here 10K, both are getting cancelled. So that means 1 plus 1 equal to 2 into VA. So this is output voltage at the first stage of op amp. Right. Now you can ignore this part of circuit. Right. Now you are having this part of circuit. Okay. Now first of all, whatever the formula here you have applied, accordingly you can consider. Here what we are doing, we are applying superposition theorem, because for this op amp, you are giving voltage at positive terminal and you are giving voltage at negative terminal. Whenever more than one input voltage present, you are very much familiar with respect to network theory subject, we used to apply superposition theorem. Exactly same concept you can apply here. So that the resultant voltage that you are getting when both the voltage sources are present in the given circuit. Yes or no? Now, with that understanding, first let us consider with respect to this particular voltage. That means we are applying this voltage at the positive terminal or non-inverting terminal. So once again, formula wise same. So here the second stage output, that is nothing but V0 equal to exactly similar formula, 1 plus feedback resistance divided by input resistance. Here also feedback resistance is 10K, input resistance is 10K. Exactly same. Just for reference I am mentioning, but you can do this calculation because just now you have done, no need to repeat, right? So just in one step you can write also. Okay, right. 1 plus RF by R1. Now in this case voltage here VB. So that is with respect to when you have considered only voltage at positive terminal or non-inverting terminal. Now second case we have to consider. That means with respect to this input voltage. Okay. Here in this case the input voltage we are giving to the inverting terminal. So now you are very much familiar regarding inverting mode op-amp formula, the output voltage minus RF by R1 into input. Okay. So here minus RF by R1. So once again 10K divided by 10K into input voltage. Here input voltage is nothing but V out1. Output of first stage is the input for here inverting terminal, correct? So V out1. Okay, right. So here 10K are getting cancelled 1. Here also 10K are getting cancelled 1. Okay. So from here you can get 1 plus 1 is 2. Sorry. Yeah. From here you are getting 2 times VB. Then minus sign, plus of minus is minus. Then V out 1, we got what? 2 times VA. See the beauty of this question. If you are able to solve like this, now you are getting the magic. Whatever they have asked in the given question, you can easily find out. So from these two, you can take 2 as common. Then you are getting VB minus VA. Now here VB minus VA is nothing but what? Your VN. Yes or no? VB minus VA. See, these two terminal voltage difference is nothing but here voltage. So VB minus VA is nothing but VN. So in the question they have asked that ratio of V0 by VN. Okay, right. So with the help of this one, you are going to get, that implies V0 by Vn is equal to 2. So answer for this question is 2. Even if they ask for overall given op-amp circuit, whatever you are having, 2-stage op-amp, for the overall circuit, even if they ask gain, the same answer, that is 2. Okay, I hope all of you got the clarity, and whatever the 2 questions currently we have received from our students based on their memory. Okay, so these 2 questions are definitely going to help you, especially for EC students with respect to the coming GATE exam that is on February 15th. And I hope all the electrical students, these 2 analog circuit questions, you people have attempted correctly. I hope so. Okay, right. So now our further memory based questions, our respective faculties will discuss in this particular session. All of you stay tuned. Thank you everyone. I will meet you all once again with the other memory based questions which I receive regarding network theory or any other subject. Okay, so accordingly I will be coming soon after some time. Okay, meanwhile, whatever the memory based questions our faculties are receiving, according to the respective faculties will be discussing the respective subject questions also. Okay, right.
Yes, guys. So can you please confirm audio video? So now we have some more questions from signals and control. So I'm going to start one more question, guys. So let me make this third, 3 here. Okay. So here the question is y of n given to you, signals and system question, s of x of n, and it is given that s del of n means impulse input, and it is given that 1 for which value of n, for n equal to for n is equal to 0, 1, 2, and otherwise 0. Otherwise 0. Okay. So examiner is asking for the output, guys. Examiner asking for the output. So we all know that if x of n and if x of n, s of del of n is given to you. So when you will put this value here, del of n, so you will get y of n as a what? Y of n you will get as a x of n into h of n. So what is the impulse response you will get? Impulse response you will get as a h of n equal to, impulse response h of n, what you will get? In place of del n, in place of input xn, when you will put del of n, then it will give you impulse response actually. Yes or no? So it will give you s of del of n here. Sorry, s of del of n. So examiner asking the final output. We know that output is nothing but output is, this is h of n, I think. This is h of n, I think. This is h of n. Yes. So yn output is nothing but x of n convolution with h of n, that we know. So first of all, if I will write h of n in place of this, if I will put na, then h of n value will be what? 1 for which value of n, guys? It will be 1 for n equal to 0, 1 and 2. Yes or no? So now you can easily solve this question. It is a very easy question, guys. How you can solve? You can just confirm the data first. How many of you attempted this question? How many of you attempted this question? Pratik, hawa mein uda denge. Very good. So this is h of n, beta. So even n equal to 0, 1, 2, 3. So in the sequence form, can I write hn is nothing but this 1, 1, 1 for which location this? So here is the arrow. So this is the one way to represent impulse response in the sequence, and one in the form of impulses also I can represent. So should I write here, because it is 0, this is 1, 2. So should I write hn is nothing but del of n plus del of n minus 1 and plus del of n minus 2. So this is nothing but my h of n, impulse response. Is this clear, bachcho? Yes. So this is the impulse response given to you. Then what is y of n now finally? What is y of n finally? So you can write the y of n value is nothing but x of n convolution with h of n, and h of n value can I put from here? Yes, sir. If I will put this value, then I will get del of n plus del of n minus 1 and plus del of n minus 2. And here just you need to apply the distribution theorem as well as convolution with shifted impulse and convolution with impulse. So x of n convolution with del n is x of n only. So when you will open the bracket, apply the distribution property, you will get first x of n, then second plus x of n convolution with del n minus 1, whatever is inside the bracket n minus 1, it will be shift with n. So it will be x of n minus 1, and the last is then n minus 2 again shifting. So it is del of n minus 2. So this is the final expression which is given in the option. So this is the only correct answer. Can you please confirm this, beta? So one of the easy question from signals and system, whatever question till now we have solved. So all questions are doable and very, very easy questions. Even if you revise properly from the classroom notes, you can easily solve those questions. And if you have revised your PYQs also, similar type of questions we have seen in the earlier also, GATE also. So guys, easy question, we must say that, and you can easily solve this question. Okay, one more question from control system. So control system, we are solving question here. So one question where g of s is value given to you. First of all, one diagram is given. Closed loop system is given to you, and here this is given first k into k dot s minus 1 dot g of s, and g of s separately given to us. This is a unity feedback where g of s value given to us as a 1 upon s plus 1 s plus 2, 1 upon s plus 1 and s plus 2. So 1 upon s plus 1 s plus 2, this value given to you gs. and asking for the closed loop system stable for, closed loop system is stable for, closed loop system is stable for. Now stable for what? Options are also given to us guys, A, C and D. So options A is stable for, it is stable for K is greater than 2. Okay. Option number B is unstable for K is greater than 2. Unstable for K is greater than 2. Now next is stable for, K is greater than 1. Stable for, am I audible guys? Do reply fast. I hope audio video clear. Yes. So stable for greater than 0, and last is unstable for K is less than 1. Like. So student, whenever such type of question will come, first of all it is a closed loop system, and we all know that the stability of a closed loop system is depends on the closed loop poles. And to write the closed loop pole equation, first of all you need to write characteristics equation. So tell me guys, when we will write the characteristics equation, because of unity feedback, can we directly apply D plus N? So characteristics equation is nothing but sir 1 plus GS HS equal to 0. However, here we have a G1S. Finally, this is the G1S. So if I will write G1S value here, this is G1, I am writing G1S HS. So D plus N I can directly write. So my characteristics equation will be nothing but this value I should write 1 plus, this is G1S means K dot S minus 1, and this GS value entirely I need to put here, so 1 upon, it will give me what, S plus 1 and S plus 2 equal to 0. So when you will write the characteristics equation, finally here just take the LCM, so you will get S square plus 2 plus 1 3S plus 2 and plus KS minus K equal to 0. I hope this is clear, bachcho. I hope this is clear. Now student, you can tell me, can I take common S square plus, if I will take common in S, then should I get 3 plus K? Should I get 3 plus K? Yes, and here you will get what, 2 minus K equal to 0. So S square plus S common, so 3 plus K, and here K minus 2 equal to 0. Now you have to check the option. It is saying the stable for K greater than 2. So here, because highest power is square guys. So don't you think to make the system stable, both the ABC coefficient, if it is AS square plus BS plus C, then no need to construct the Rautherwich. We just need to maintain ABC positive. So here K plus 3 should be positive. So if I will make here K plus 3 is greater than 0, then one limit I will get K is greater than minus 3. And other is 2 minus K must be greater than 0. So it will be 2 is greater than K. So it means K is less than 2. So we must say that if system is stable for K is less than 2, system is stable for K is less than 2. So of course it is unstable when K is greater than 2. So of course it is unstable for K is greater than 2, because it is stable for K is less than 2. Because when you will take unstable for, and other options also you can eliminate, stable for K greater than 2. Stable for greater than 2, no, because stable for K less than 2. So that is why option number A wrong. Stable for K greater than 1. K greater than 1, of course, if K greater than 1 means 3 also there, 5 also there, because K less than 2 is required, so that is why C also wrong. And unstable for K less than 1. Here it is saying that K value greater than minus 1 and K value less than 2. So K value less than 1 for some values, but not for all, because if K less than 1 means entire negative part also come. Yes or no? So that is why this is also correct. Answer is option number B for Bombay. Unstable for K is greater than 2. This is the best option among 4. That is why we need to choose the best option. Now, one more easy question from the state variable part, guys, from the control system only. So I am solving one more question from control system. So control system question where a state matrix is given to you. So first of all, x dot t, this is state equation, axt plus but, axt plus b r of t given to you, and yt also given to you as a. So these are the given data I am writing here. Yt is given to as a cx of t, okay. And matrix is also given to us. A matrix is given to you 0, 1, minus 2, minus 3. 0, 1, minus 2, minus 3. B matrix is also given to us as a 0, 1, and C matrix is also given to us as a 1, 0. Now, sum of magnitude asking for, examiner is asking for sum of magnitude of poles. Sum of magnitude of poles is, so it means it is asking, I think, NIT question, guys. So again I must say that easy question only. Why easy question, guys? Because it is just asking for the pole, no need to write even transfer function. Do you know the transfer function formula? C dot Si minus A inverse dot B plus D, yes or no? So C dot Si minus A inverse dot B plus D, when you will write Si minus A inverse as a adjoint of Si minus A upon determinant of Si minus A. So right now, because examiner only asking for the pole, so I no need to write the transfer function. You should not waste the time. Pole equation is directly nothing but mod of Si minus A equal to 0. In terms of engineering mathematics, you are saying this is eigenvalues, and in terms of control system, we are finding the pole by determinant of Si minus A equal to 0. So if I will find fatafat say Si minus A, if you are my classroom student, we know how to directly write Si minus A, because Si means diagonal coefficients S. So here is S minus 0, so S only. Here is 0 minus 1, so minus sign change. Here is 0 minus minus 2, so it is plus 2. Now here S minus minus 3, so it will be S plus 3. Now I just need to find the determinant of this. So if I will find determinant, I need to multiply this. So it will give me S square plus 3S minus minus plus 2 equal to 0. So of course there is a partition, so I can make the partition as S plus 1 and S plus 2. So of course it is an overdamped system, so two real poles, S equal to minus 1 and minus 2 are the poles. But examiner is asking for the sum of magnitude of poles. So if you will take the magnitude of sum of poles, if you will take sum of magnitude of poles, you can just check the language, guys. If this is the language, so if I will, how many poles I have 2 poles, minus 1 ka mode and minus 2 ka mode. If I will take the magnitude of some poles, then of course I will get the 3 answer. So you should check, guys, what is the exact language correct answer for this question. If asking for sum of magnitude of poles, then the final answer must be 3 for this question, guys. Chali, we have one more question from the control system, and that is a beautiful question, came from the phase margin concept. So what is the question? First of all, the given data I am writing here, whatever given data. So first given data value, guys, first a closed loop system is given to you, a plus minus closed loop system given to you. Two boxes are connected in the cascade, one is D of S and one is G of S. One is G of S, okay, and here we have connection like this. So here we have R of S, and here we have Y of C of S, okay. So what is the D of S value given to us, guys? So D of S value given to us as a 1 plus KDS, 1 plus KDS. This is the DS value given to you, okay, and GS value also given to us. GS value also given to us, that is 1000 into root 2. 1000 into root 2 upon S into S plus 10 ka whole square. S into S plus 10 ka whole square. Yeah, this is also GS value given to you. And what is whatever the other values given, that is phase margin is given to you as a 45 degree, and omega GC, grain crossover frequency, is also given, that is 10 radian per second. And examiner asking for, we need to find KD value. KD is the question mark. So this is all about the given data, guys. This is all about the given data, okay, for this question. Now how to solve? First of all, tell me. If you have attended control system classes, again very easy question. Why? Because first of all, phase margin is given to you. Do you know? I am solving here. So phase margin concept, phase margin is nothing but 180 degree plus phi. Yes or no? If I will put the value of phase margin here, then it will give me 45 degree equal to 180 degree plus phi. So don't you think phi is nothing but minus ka 135 degree? Yes or no? And by the definition, what is the phi? Sir, phi is nothing but angle of Gj omega Hj omega, angle of Gj omega Hj omega at omega equal to omega Gc, give us the phi value. Bolo hai na? Now I already have phi value minus 135. Now first of all, I need to write Gj omega Hj omega first. So if I will write Gs Hs here, Gj omega Hj omega, before that I should write Gs Hs. Gs means this is the entire Gs. So G1 as it is. So I should multiply these two. So if I will multiply, then should I get 1 plus KDS? So I should write here, sorry. I should write here 1 plus KDS. I should write here what? 1 plus KDS dot 1000 root 2 upon dot 1000 root 2 upon s dot s plus 10 ka whole square. S dot s plus 10 ka whole square. Yes. Now student, this is GSHS. First of all, I need to put s equal to j omega. So if I will put s equal to j omega here, I am just solving in detail so that other students will get perfect solution here. They will not have a single doubt. So 1 plus kd j omega, and here 1000 root 2 upon, you will get in place of s, I am just replacing j omega. So j omega plus 10 whole square. Now student, I need to write the angle equation. What I am looking for this. Angle of Gg omega at omega Gc give me phi, and phi value I will equate to this. So whatever unknown value that will come. So omega Gc value also given to me 10, and I am looking for Kd. Okay. So first of all, you should find the angle of Gj omega, Hj omega. Do you know how to write the equation, guys? Angle. So first of all, if you write the angle, suppose that I am writing the angle from numerator first, or if you want to write j omega angle also, so you can write the angle. First of all, j omega angle is 90 in denominator. When it will transfer in numerator, it will be minus 90 degree. What is the angle of for the numerator part? So of course plus. So tan inverse imaginary upon real. Imaginary means omega kd or kd omega upon 1. And 1000 root 2 angle is 0 only. What is the angle of this? So angle because of power 2, so minus because of term mentioned in denominator, when the angle shift in the numerator, sign will be changed. So minus ka 2 tan inverse and imaginary upon real, so omega by 10. So this is all about the angle equation, guys. This is all about the angle equation, and this angle equation will become phi at omega equal to omega Gc, and that is nothing but 10. So if I will put this value, then it will become phi, yes or no? So what is phi now? I am substituting wherever omega. If I will put omega Gc here, if I will put omega Gc here. And do you know omega Gc value is what? Omega Gc value 10. So when you will put, it will be phi. So minus 90 plus tan inverse. Here omega Gc value is tan kd upon 1, and here is minus ka 2 tan inverse and tan by 10. And you can say it is cancelled. So tan inverse 1 is 45, 45 into 2 90. So if I will finally say that phi is nothing but minus 90 degree plus tan inverse tan kd and 45 to minus 90. So again, so this is my finally phi, and I already got phi value in the last slide. In the last slide, phi value we got minus 135. So I am just equating this. I have some space here, so I am doing here. Phi value is nothing but minus 135. I am equating in the left hand side phi value, and right hand side I am getting minus 90. Minus 90 will become minus 180. So minus 180 plus tan inverse tan kd. So now tell me, guys, when this minus 180 shift in the left hand side from RHS, sign will change. So it will become plus 180 minus 135 gave you ultimate 45 degree. 45 degree is equal to tan inverse of tan kd. So when you will take tan both side, or this, when you will shift this tan inverse this side, so it will become tan 45, and tan 45 is equal to tan kd. So tan 45 is 1 only. So 1 is equal to tan kd. So finally kd value is nothing but 1 by tan, and kd is nothing but 0.1. So 0.1 is nothing but the final answer for this question. I tried here for the detailed solution. That is why I explain in a, I took more space to solve you in a properly. Each and every step I have solved in detail, guys. Okay. So I think these are the questions that we have received till now. So I think we have some more questions, guys. Some more questions. We have some more questions. Chaliye. So I will just check with my team members. So if they received some more questions from EE Gate 25 paper. So we have Vipin sir with us. So Vipin sir, come. So first of all, I just want to ask you ki how was the paper and what is the difficulty level of?
Sir, sorry, the paper was not that much difficult,
Okay.
and it was not that much easy also. So I can say it was on moderate side. 23-24 paper was a tough paper.
Okay.
So as compared to last year, this year paper was very much doable.
Okay.
So subjects like power electronics, signal and system, control system, they were on easy side. Very easy questions came from these subjects. Measurement, digital, there also you can easily do.
Okay.
But students are very much disappointed from machines and power system, because there were very tricky questions from these two.
Oh,
Lengthy type questions, and the weightage is also not that too much from machines,
Okay.
which is expected to give a lot of marks.
Correct. Generally 10 plus marks.
Yeah, but I think it was only 6 to 7 marks that I have seen. Yeah. Maths was, I think, on average side, right? And GA was very easy. So this was the analysis of the paper, sir.
So we have already solved many questions from control signal, digitals, and even analog. So you have some questions from core subjects.
Even three power electronic question exactly came from the gate score booster that I have session. So if you have attended, you must have done those questions.
Okay, so you have the question now?
Yeah.
So please start the solution. Okay?
Sure, sir. So student, so there was one question from DC to DC converter that I can say, okay, and similar question I have discussed during the gate score booster session. I hope that you people have attended, in which there were different category of buck, the converter was given, and it was asked that how much is the power delivered from the load to the source. Let me draw the circuit diagram and then you will understand. So we had a battery and the diode was connected in this way, okay, and then we have a combination of MOSFET. Okay, then we have a combination of MOSFET and the diode was given. You can consider it as a switch, okay, and then there was given a current source like this, okay. This was having 15 volt, so input voltage was 15 volt. This is the diode given, this is the switch, and the current source was having a value of 10 ampere, right. You were you were asked to calculate that how much will be the power delivered by this current source towards this battery, right. So what you can see here, in generally what we have to do in these kind of questions, so just see the input voltage. Input voltage is a constant DC voltage, okay. You have to use the fundamental knowledge that you have, okay. So V input, or you can write it Vs. Now when the switch will be on, at that time what will happen, and the duty ratio was given, duty cycle was 0.4, okay, so D was 0.4. Now when the switch will be on, at that time what will happen, let's suppose that this is your output voltage, okay. So when the switch is on, so at that time what will be the output voltage, it will be 0. When the switch will be off, at that time what will be the output voltage, so the load will drive the things here. So at that time when the switch will be off, at that time what will be the output voltage, it will be exactly equal to the input voltage, right. Switch and diode cannot be turned on simultaneously. So if the switch is on, diode will be off. If the diode is on, switch will be off, right. So when the switch is off, at that time your diode output voltage will be exactly equal to the input voltage, that is 15 volt. So what you are getting here is, you are getting this kind of voltage waveform for the output, correct. So this is 0.4, okay, or you can write it the on time, okay, and this is basically the off time. So you are getting output voltage during the off time, correct. This is the output voltage and the level is 15 volt. Now you know that in such a waveform, if you have to calculate the average output voltage, the average output voltage will be Vs into 1 minus D. How much is Vs? It is 15. 1 minus the D is 0.4. So how much you will get? You will get 9 volt, okay. So 9 volt will be the output voltage. Now how much is the power delivered if you have to calculate? So the output power, or the power delivered by this current source, will be V naught into the I naught, right. So how much is V naught? V naught is 9 and I naught is given 10. So you will get 90 watt. Right. Same question we have done in gate score booster series. I hope that you all have seen that question, okay. Similar kind of question were there. The output power was given, okay. Different things were asked there, but the way we have to do this question, we have discussed there, right. So this was one question that we have seen from power electronic. The other question that we have from power electronics, so I hope that you all have done this question. The other question was, we have been given the input voltage Vt of a AC to DC converter, which was 300 sine omega t, and we were given the current, which was a non-sinusoidal current, okay. So when the converter will operate, the current will become non-sinusoidal, and it was 10 sine omega t minus pi by 6 plus 2 sine omega t plus pi by 6, and it is 1, sorry, we have 3 here as well. So 3 omega t plus pi by 6, and we have 1 sine 5 omega t plus pi by 2. This was the current given, right? So sinusoidal voltage, for non-sinusoidal current we have. Now what we have to calculate here is what is the input power factor, right? You have to calculate that what is the input power factor, okay? So you know that in such a case, this is also one of the gate score booster session, question that you can see, right? So we have practiced these kind of questions and they were the part of the gate exam right now. So the input power factor, right? Input power factor will be the current distortion factor into the displacement factor, or fundamental displacement factor we can write, right? Now how to find the current distortion factor? It is the fundamental RMS value of current divided by the total RMS current into fundamental displacement factor will be cos of theta 1 minus phi 1, where theta 1 is the angle of the voltage and phi 1 is the angle of the fundamental component of current, right? Now what is the fundamental RMS current? It will be 10 by root 2. And how you will find the total RMS value of current? It will be 10 by root 2 square plus 2 by root 2 square plus 1 by root 2 square, correct, into cos of, here the angle is 0, the angle here is pi by 6, so you can write pi by 6, cos pi by 6. Now when you will solve it, you will get 0.84, correct. This is how you could have solved this question. I hope that this is understood, correct. So these were two easy questions. Now next question that we have is from, again from DC to DC converter, okay, it was from buck converter but asked differently. What they have given the capacitor current waveform. This question is from buck converter, so there was a buck converter, right, and they have given the capacitor current waveform for the buck converter. Right. So they have given capacitor current waveform and the waveform was like this. Right, the time is in microseconds. And these values were 0.1 to 0.1. This is the capacitor current waveform given, right? And after that they have given that if the input voltage is 30 volt, right? If the input voltage is 30 volt, then what will be the value of the inductor in millihenry? Correct, you have to calculate that what will be the value of the inductor in millihenry. So from this capacitor current waveform, what you can see is that peak to peak ripple in current. So peak to peak ripple current, that is delta IL, will be 0.2, and you know the formula, it is D 1 minus D Vs over F into L, right? Or what you can do, you can write 0.2 D 1 minus D Vs into T over L. You have to find L, so L will be D 1 minus D Vs into T over 0.2, correct. Now what will be the value of D, right? So the D value here will be 25 over 50, okay, the on time over the total time. So you will get 1 by 2, right? Now put the values here. So 1 by 2 into 1 minus 1 by 2 into the Vs is given 30 and the time will be 50 microseconds, right, divided by 0.2. So now when you will solve it, you will get 1.875, okay, 1.875 millihenry. That will be the answer, correct. So this is how you have to solve this particular question. Okay, this was from DC to DC converter. How many time I have told you that DC to DC converters are very important for GATE exam, and you can see they have given, and they can give you marks up to 3 to 4, right? And they have given 2 questions carrying 3 marks. So you could have scored these 3 marks easily if you are very well prepared for this particular section, correct? Now, this is not the end of power electronics. We have 2 more questions from power electronics. So the next question that we have is, we have been given a circuit like this. An AC source is supplying to an inductor through an SCR, right? This is the SCR given, and this AC source which is given is having a value of 230 root 2 sine omega t, correct? For thyristor, the alpha value is given 0, the inductor value is given 100 millihenry, the inductor value is given 100 millihenry, right? Omega is given 2 pi into 50 radian per second, right? We have to calculate the peak value of inductor current. What will be the peak value of the inductor current, correct? So alpha is given 0, so this thyristor will behave like a diode, right? And you know that in such a case, okay, what you have to do, you will apply this Vm sin omega t equals to VL, or you can say L DIL by dt. From here, when you will solve it, so you will get Vm by L sin omega t, okay? And if we integrate it, then what we are going to get, let's suppose that this is I naught, or let's suppose that this is IL, okay? And we can write it Vm by omega L minus cos omega naught t plus k. Now at omega t equals to 0, IL will be 0, right? So from there you will get the value of k to be Vm by omega L. Now when you will put these values, IL will be Vm by omega L 1 minus cos omega t, correct? Now when you will plot it, you will get a waveform like this. If we put omega t to be 0, it will be 0, right? If we put omega t to be pi, then it will be Vm by 2 Vm by omega L. If we put 2 pi, then again the current will be 0, okay? So how much is the peak value? The peak value we will get at pi. So at omega t equals to pi, when you will put, you will get IL peak, and IL peak will be 2 Vm by omega L, right? It was an MCQ question, and the options also were matching with the answer that we are getting. So twice Vm by omega L. Now twice into what is Vm? Vm is 230 root 2 upon omega. We can write 314 into the L value is 100 millihenry. So when you will solve it, the answer that was coming is, the answer that we were getting is 20.71 amperes, right? And it was matching with the given options. So this is how you could have solved this particular question, okay? Again, from power electronics. And if you will visit our channel and if you will go to the playlist, you will see that in foundation classes we have discussed the same question, okay? Nothing is different from this question and the question that we have discussed in our foundation series. Now we have another question from power electronics after this, that was from inverters, okay? So I hope that you are getting the right answer for all these questions, okay? And you people also have attempted these questions. The next question that we have is from inverters, right? Next question is from inverters. And what was given? We were given 3 modulating waveforms. There were 3 modulating waveforms for 3-phase inverter, and those were VA, that was 0.8 sine omega t. Next is VB, that was 0.8 sine omega t minus 120. The next waveform was 0.8 sine omega t minus 240 degree. These were the three modulating waveform, right? We have carrier waveform of amplitude varying from -1 to +1, and the carrier frequency was 10 or 15 kilohertz. Okay, I don't remember exactly, it was around 10 or 15 kilohertz. Power electronic question were conceptual, sir, and your lecture helped me a lot. Thank you very much. Right, so carrier frequency were also given. Okay, what we have to calculate? We have to calculate that what is the fundamental RMS value of the phase voltage, right? What is the fundamental RMS value of the phase voltage? So in all my lectures, even in the gate score booster series, I have done a lot of questions on modulation index, and I told you repeatedly that guys, please prepare this topic. You will definitely get a question from these particular topic of modulation index, and here you can see, right, there was a question from this topic. So for that, what will be the value of this? So phase peak to peak phase voltage, fundamental phase voltage, it has a formula that it is modulation index time VDC by 2, right? Now what we have to calculate here is the RMS value. So the RMS value will be MA VDC by 2, and we will divide it whole by √2, right? So what you can see that modulating waveform has an amplitude of 0.28 and the reference is varying from -1 to 1. So the modulation index will be 0.8 and the VDC, yes, VDC was given 600, right? So VDC was given 600 volts. So 600 by 2 into √2, when you will solve it, then it was coming 169.3, 169.73 volts. So that will be the answer for this question. Okay, guys, just go to our YouTube playlist of our YouTube channel, just visit to Gate Score Booster series, and what you can see that out of these 6 questions, at least 4 were exactly from the Gate Score Booster series that I have taken, right? So if you have attended, you could have solved this question, right? Now there was again another question, and one thing I was repeatedly telling that in 23 and 24, power electronics has given not that much question as the repetition of power electronics has, right? So this year I was saying that it will give a lot of question, and you can see it has given a lot of question. Overall weightage of power electronics was around 11 marks, correct? So now after that we have another question. There was a rectifier, right? There was a rectifier which is given 3-phase supply, right? So we have a rectifier which is being given 3-phase supply, and it is supplying to an RLE load, and in that RLE load this was 500 volt. Okay, and I think the inductor is having 100 millihenry value. Resistance was given 1 ohm, correct? Now the output voltage of the converter, this V0, we have been given an expression that V0, average V0 is 400 1 plus cos alpha by 3. Okay, they have given this value, and they have given the power absorbed by R is 64 watt and L is very high, right? L is very high. Then what will be the value of alpha? You have to calculate the value of alpha, and there were 4 options given, right? So if L value is very high, so average and RMS output currents will be equal. Okay, so normally we used to calculate power across the resistance with RMS value. Now because L is very high, so average and RMS quantities will be same for current. So what we can do, we can equate it like I0 square R. Now this has been given 64, so I0 square into resistance is 1. From there you could have calculated I0, which will be coming like 8 ampere. Now when you will apply the load side KVL, average inductor voltage will be 0, right? So load side KVL will be V naught average, this will be equals to E plus I naught average into R. So E is 500 plus I naught you have calculated 8, resistance is 1, and V naught average they have given 400, 1 plus cos alpha by 3. Now when you will solve it, you will get alpha value as 35.9, right? Instead of solving this equation, what I have done in the exam, that when I have reached to this mark, I have just put the value of alpha to be 35.9, which was option number A, and immediately I got both the sides equal, and that is how I got the right answer instead of calculating it, right? So this is what we have seen from power electronics, right? This is what we have seen from power electronics. I hope that you all have done very good in power electronics, right? Just a second. Okay. Now we have one question from power system, and which is related to capacitor bank. I hope that you have done that question as well. So this question that I have is from power system. Okay, from power system, this was the only easiest question that you could have done. Rest all the questions were very tricky, right? It was not easy to answer power system. What has been given is that a 3-phase induction motor is there, okay? 3-phase induction motor is having a rating of 4 kV, okay, and 390 kVA and operating at 0.77 power factor, right? Now a capacitor bank is used. A capacitor bank is used to improve the power factor up to 0.85, right? 0.85. Then what you have to find? The line current drawn by capacitor, right? This is what we have to calculate. So guys, you know one thing, that if capacitor we are using for correction of power factor, then 3-phase rating of that capacitor or capacitor bank is given by P tan phi 1 minus tan phi 2, right? How to calculate P? So P is basically the rating of the, we can calculate from the rating of the machine. So you can just calculate it by 390 into this 0.77, the power factor of the machine which is given to us. This will be the P value, okay? Now what will be tan phi 1? Tan phi 1 will be tan of cos inverse of 0.77 minus tan phi 2 will be tan of cos inverse of 0.85, correct? So by solving this equation, you will get QC. QC was coming 41.44 kVAr, right? Now once you got the QC, then just equate QC with root 3 VL IL sin phi, because it is the capacitor, so phi angle will be 90. So QC is what? QC is 41.44 kVAr that you are getting, root 3 into the voltage. The line voltage was given 4 kV, right? And IL is what we have to calculate. Phi will be 90. So when you will solve this equation, you will get the value of line current, which was coming as 5.98 amperes. So this was an easy question, right? There was one more question from power system. They were asking that if suppose there is a power failure and UPS is operating, okay, and UPS is supplying the appliances, then UPS can be considered as what kind of bus, okay? Is it a slack bus? Is it a PV bus? Is it a PQ bus, or it is a PVQ bus? Okay, so it's a case of grid failure, like grid fails and then something is operating. So UPS operation is similar to that. Okay, so if suppose the power supplies went out and UPS is operating, that combination can be considered as PV bus, right? Because everything is re-estimated and calculated, so it cannot be a slack bus because losses are known to us. Okay, so it will be a PV bus, right? There was one more question from power system, but I don't have the exact data. Once I will get the data, I will discuss that. That was from economic load dispatch. Okay, so this is from power electronics and power system that we have. Okay. Right. So now after power electronics, power system, Priyanka ma'am will discuss some more questions from mathematics and general aptitude. So stay tuned to our channel.
Hello everyone. So till now many questions we have already solved, memory based question whatever we have received till now. Many questions we have provided you detailed solution. Now I have one more question from control system, and after that we will start the engineering mathematics and general aptitude. Priyanka ma'am will start. So guys, question is from control system, and it is a very basic question from the time domain analysis, and here a table is given to you. where T and C output given to you, output equation CT given to you. So you can please confirm the data, guys, those who attempted the GATE exam, 0.6, 1.6, 2.6, okay, and 10, and this is steady state value, that is infinity. So this value is given to you 0.78, okay, 1.65, okay, next value is 2.18, and here value 2.98, and here value 3. So it means examiner asking for the time constant is. The question is the unit step response for the first order system, and this equation is given to you. This table is given to you. Examiner asking for the time constant is. The examiner asking for the time. I am writing in a short form only. So ABCD options are like this: 1, 2, 3, 4. Now, guys, how to solve this question? First of all, do you know in the unit step response, if you know the basic concept of control system, chapter number 2, that is time domain analysis, for a second order system, I told you the unit step response, the steady state value is depending on only two parameters. One is K, that is DC gain of CLTF, and one is A, that is amplitude of step signal. So here this is unit step response given to you, so A value is 1. But as I told you guys, who will make changes in the steady state value? Of course, the steady state value is 3. It means the DC gain K value must be 3. DC gain K value must be 3. Yes or no? And that is why steady state response is this. So what is the CT equation? So ideally we have the CT equation like this, guys. K dot A dot 1 minus e to the power minus t by capital T. Where what is K? You can say that where K is the DC gain of CLTF, where D is the DC gain of closed loop transfer function, or you can say that K is DC gain of CLTF, and one more thing, guys. What is A? A is the steady. A is the magnitude of or amplitude of step signal. Magnitude of step signal. Yes or no? That we know that. So finally here steady state value is 3. The steady state value is 3 actually. So you know that it is Ka. Ideally it is Ka, but right now it is 3 given to us. So it means what is the equation now? If I will compare the equation, the steady state value is 3. So can I write here 3 dot 1 minus e to the power minus t by capital T? Whatever the K or A, but the final value is 3. Final value is 3, yes or no? So steady state value is 3, so I am putting here steady state value. This value is of course equal to C infinity. This value is of course equal to C infinity, K dot A. So magnitude of step signal. So here is 3 and CT value. So now in this equation, if I am looking for capital T is time constant, just need to simple mathematics, apply CT value. T and CT is given to you. This is CT now. So if I will put first value, CT value, if I will put 0.78, and here is 3 and 1 minus e to the power minus t. T means I need to put 0.6 upon, here is capital T. So if you will just simply divide with this, so if you have the calculator, can you please divide? So if you have the calculator, can you give the calculator? So can you please calculate this? 0.78 divided by 3, put off it. So we'll calculate this. So I think 0.26 something you will get. 0.26, 0.26, yes. 0.26 is equal to 1 minus e to the power minus 0.6 upon capital T. Now when you will shift this part, guys, this will be positive. So e to the power minus ka 0.6 upon t is equal to 1 minus 0.26. And that will give you what? 0.74 of course. And here is e to the power minus ka 0.6 upon capital T. Now you just need to left with log both side, ln both side, and of course 0.74 ln is negative only. So minus, so I am writing here minus ka 0.6 upon capital T is equal to what? Minus ka? Minus 0.30. Okay, so again minus minus got cancel, guys. When you will finally find T now, then you will get 0.6 upon 0.3. The final answer will be 2 seconds only. So time constant answer is 2 seconds, and this is the correct answer, guys. Option number B for Bombay. So I hope many of you already attempted this question. Easy one, this control system, easy question only. Now we will start engineering mathematics and aptitude. We have done, sir. Done? Okay. So now we will start, guys, engineering mathematics and aptitude part. So many questions we have completed, and if some more question you will share in Telegram group, we will provide you the detailed solution at earliest. Okay. So just wait. Now Priyanka ma'am will start maths and aptitude part.
Yeah. Yes. Okay. So welcome dear students. Now I'm having questions from the engineering mathematics and general aptitude. Okay. So let's start with the very first question of the general aptitude, guys. The basic question, the very simple question. It's talking about 3 to the power 81 divided by 27 power 4 and whole power 1 by 3 is what? If you guys were there in the paper, so you guys can confirm also about the data whether it is correct or not. Okay, if there is a correction in the data, you can confirm here. So the very first question is the simple question, very easily we can solve it, bacho. First of all, this is 3 power 81. Okay, we can write down this as it is. Means the denominator which is in the 27 power, we can convert it again in the 3 power and then base of the numerator and denominator will be same and then you can solve it. So this 27 power 4 is basically 27 is 3 power 3 and this is power 4. Alright, and whole power 1 by 3. When I'm writing this is 3 power 81. This is 3 into 4 12. So this will be minus 12. When base are same, the power can be added or subtracted according to the value whatever is mentioned here. This is 1 by 3. When you are writing this is 69 and power 1 by 3. When we are cancelling this is 3 2 times or 3 times. So this should be 3 power 23. The answer should be 3 power 23, guys. Alright, the very first question. Then the second question is the basic question from the analogy, as this type of question has been asked in both the days. Yesterday, both the session, this question has been asked, this pattern of question, analogy, word analogy I will say. Today also in the morning session, mechanical question has been asked. Okay, ship and lion type of question was there. And here again we are having a question which is talking about analogy, the same relation which is given to you between these two, the same to same you need to follow. for the remaining one. As I'm not having options here, but what I can see, it's good and evil. So good and evil are antonym of each other, opposite of each other. So here also genuine is mentioned here, it should be the opposite. So if you are writing opposite, it can be fake, okay, it can be false, it can be whatever options available. As one of the student mentioned, key option is counterfeit. So this is the answer. If this is available in the option, so counterfeit is available. So this is the answer. If even here you can write down, sorry, insincere is also there, fake, false, okay. Genuine's opposite, antonym we are looking. So counterfeit should be the answer if it is available in the option. So the relation very easily we can see is about the antonyms. Okay. Then, okay. Yes. Then the next question again from the general aptitude, if I am talking about, so yeah, again the question of general aptitude, which is the basic English question. This is from the GA. This is also from the GA. And this is the question again from the GA. The question is talking about Ramya dash, okay, fill up is there, go to office. The basic grammar related question, go to office yesterday. It's talking in the past tense, yesterday, because she dash well. Okay. So if in the options, the very easily I can understand ki Ramya go to the office yesterday because she well. So it should be Ramya could not or couldn't go to the office yesterday because she was not well. When it is mentioned yesterday, so very easily we can understand this is a question of past tense, and when this is a question of past tense, the answer should be like this only. Okay? Yes. And one more interesting question I am having from the general aptitude again, and this is interesting question. It's given to you one circle. We can make here some information mentioned in this circle. Okay. And okay, first of all I should make here the lines as well. 1, 2, okay, how many elements mentioned here? Okay, 1, 2, then it should be 3, third one, and I think one more is there, fourth one. Let's see. If it required more, we will make it more, but let's write down the values here. It's mentioned to us, the question is here like this. What is the question? Yes, this is the question. Ki EF, then HJ, alright. Then here two blank spaces mentioned, first and second. This is 30, this is 80, this is 35, and this is FG. Okay. So, and they mention here if EF and HJ is coded as 30 and 80 respectively, so then find out the unknown values first and second. Okay, respectively. So first of all, what is mentioned, EF is coded as an 30, all right, and HJ is coded as an 80. So we need to understand what relation we are having here in this case first of all, and then accordingly we can approach, or accordingly we can solve it. So when I am taking this EF is mentioned as an 30. So what is the number when we are talking about alphabetical order? So A, B, C, D, E comes at the 5th position and F comes at the 6th position. 5 into 6 is 30, correct? In the same manner, when I am checking with the HJ, it's mentioned to us the coding of HJ is 80, right? H is coming at the 8th position, J is coming at the 10th position, so 8 into 10 is 80. So in the same manner, when you are asking to me the unknown quantity, that should be here for FG and this should be here for the 35. So FG, all right, F and G. F is 6 and when you are writing G is 7. So it should be 42. 6 into 7, 42. At this place I should write down 42 for FG. And when this is 35, 35 is already there. So 35 means the composite number 35 can be written as in 5 into 7. Oh, okay, or 7 into 5, whatever is possible. So here when I am writing 5 into 7 or 7 into 5, so it should be 35 is 5 into 7 or 7 into 5. When I can see here, how I will write down? I should write down 5, 7 or 7, 5. When I am checking here every in these two or even in this one also. In these three options, smaller number comes earlier. है ना? Smaller rank is coming earlier. So it should be 5. 5 means E and 7 when we are talking about this is G. So it should be EG. At the place of this one, it should be EG. It's asking about the first and second. So first will be EG and second will be 42. These two will be the answer according to the options. As I am not having options, so according to the options you can check and you can just confirm about the options as well. Okay, so let's come to the next one. All right, so and now we are having the questions from the engineering mathematics. So the very first question of engineering maths, let's see what question we are having. So this is the question from the directional derivative vector calculus. I will say it's talking about ki for the given function, for the given function v, which is x square plus y, x square plus x plus y square plus 1. Okay, the value of directional derivative, the value of dd, directional derivative in the direction of the a vector, which is ax cap twice of ay cap. Okay, at the point 0 0 origin. All right, so let's see how we can solve this question. So it's talking about the directional derivative dd, which we know very well ki gradient of the given function. Okay, whatever the function is here, so gradient of the given function dot product with the a vector. A vector, okay, basically this is e vector, so I am writing e vector as an a vector by magnitude of a. So first of all, now this a vector we need to write down smartly. This is I cap plus 2j cap, and the magnitude a vector by magnitude of a is I cap plus 2j cap divided by 1 plus 4, which is root 5. All right, and let's find out the gradient of this given function. When I'm finding the gradient of any function is basically del f by del x. Okay, for the complete function we need to find out the partial differentiation with respect to x. If the function is f, if the function is v, so del v by del y with respect to j, del v by del z with respect to k. Okay, so when I am finding the partial derivative with respect to x, so this is 2x plus 1. So 2x plus 1 I cap. With respect to y, this is 2y and there is no k. So 2y j cap. Point is 0 0, so you can write down the result gradient of v at the point 0 0, which is 1 and only 1 I cap. Okay, because this is 2y na, to 0, so this is only I cap. Now I am looking for the dd, directional derivative. So directional derivative is I cap dot product with the I plus 2j divided by root of 5. I dot I will be 1 and there is no j, so that will be 0 only. So this is 1 by root 5, which is I think 0.45 when we will solve in the numerical answer. So I think this is an NAT numerical answer type and very easily we can write down this result. Now the next question which I am having from the engineering maths is from the complex variable. Okay, sorry. The next question is from the complex variable of the engineering maths again. And this is the question ki what it is asking, the function for the integral close integration C, what is this IZ dz, where it's given to you the closed curve is a unit circle. The closed curve is a unit circle. Unit circle means mod z is equals to 1. The closed contour is unit circle, mod z equals to 1. And they are asking about the result. So first of all now, it's talking about mod z equals to 1. We need to check, okay, this is the question of complex integration. But when I am checking here this very easily, I can see ki iota z is a function which is analytic everywhere. Hai na? Which is analytic everywhere. For this the Cauchy-Riemann equation satisfy. When you will check, so it will satisfy. Okay, then directly using the Cauchy's integral formula, I can write down when this is analytical inside this closed curve, so fz dz equals to 0 using the Cauchy's integral theorem, not formula. So I can write down directly कि since this function is analytic, iota z is analytic everywhere in this given, okay, for this given function, there is no singularity, so directly you can write down the result, the integration for this closed curve iz dz equals to 0. But if you want to solve it, no, we want to solve, so this is the method number 1. If you want to solve, then also it is possible to solve the question. It depends on the students ki, although it's not required, the function is analytic, we can see directly. But if still you want to solve, so we need to go with the this one. What is the closed contour? I is iota z dz. Okay, if it is possible, so we can take z equals to e power iota theta. So dz will be iota, okay, because if I will not solve now, then this will be, means if I will not put here, I will not substitute this in the Euler's formula, then we are not able to solve this question very easily. So iota e power iota theta, and we know very well this is a closed contour, the unit circle. So for the unit circle, theta will exist between 0 to 2 pi. Take a complete angle. So then we can write down here the result. So this I will be integration theta equals to 0 to 2 pi. I is already there. Z is e power iota theta, or dz is iota e power iota theta d theta. I can write down iota is iota square. We can take it outside. Theta equals to 0 to 2 pi e power 2 iota theta or d theta. Okay, iota theta plus iota theta will be 2 iota theta, and we can write down iota square is -1. If you want, you can write down here the -1 itself. When we are writing, now we need to go for the integration. When we are going for the integration, acha, it depends on you after that also, but I am suggesting here only we can go for the integration 2 iota theta by 2 iota, and the limit is 0 to 2 pi. So 2 iota is there, so this is -1 upon 2 iota. Options available? Nahi, options theek hai. So and this is, when I will put the limit 2 iota, theta is 2 into 2, 4 pi, and this is what is this? This is 1. Okay, e power 2 pi is 1, 2 pi square again, that is 1 square is again 1. So 1 minus 1, this will be 0, 0 by something is 0, so the result again we can get as a 0. So it depends on you ki how you can solve this question, first or second, both forms are good, we can solve it. Now, the next question which I am having from this engineering mathematics, this was the second one, this is the third question of engineering maths, and this is talking about ki if A equals to, the matrix A is given to us 1 1 1, the next is -1 -1 -1 0 1 1, okay, and B equals to -1/3, nahi, +1/3 -1/3 or 0, and they are asking about ki Ax is equals to B will have which type of solution, है ना, infinite solution, unique solution, no solution, one solution, two solution, whatever it is. So let's solve. First of all, the basic question we can solve here using using the rank. So let's write down the augmented matrix AB, and I think in the one line we can solve this question. 1 1 1, this is 1 by 3, this is minus 1 is there na, I want to take minus 1 outside this closed curve. Okay, so this is 1 1 1 or 1 by 3, this is 0 1 1 or 0. I can see here the order is 3 cross 4. Order is 3 cross 4, so rank of A is less than equals to 3, rank of AB as well less than equals to 3. When we are checking here, first and second row are identical throughout this minor. When you are checking the very first minor value, the 0. When you are checking the second minor value, that is also 0. So we can very easily conclude that since here first two rows are identical, so all the minors of 3 cross 3 in this matrix will be 0. Hence, the rank of matrix A will be less than 3, as well as rank of AB is less than 3. So both will be less than 3 here. Okay, reason is very much clear. All the minors are 0. So rank of A and rank of AB both will be less than 3. If it is less than 3, then you need to check whether it is 0, non-zero, hai na? So when you are checking the very first minor, even any of the minor, when you will check here, when I am checking the second minor, I can say this is non-zero. So which is less than 3, so then you can write down directly ki rank of A and AB will be equals to 2. And this is the matrix which is having how many variables? 3 variables are here. So very easily we can say rank of A and AB is less than 2 number of variables, number of unknowns. So hence this is having infinitely many solution. So the result should be infinitely many solution. Infinitely many solution. Okay, I don't know what options available, but in the option surely it should be infinite solution. If yes, you guys can confirm. Okay, I am sure one of the options should have the infinitely many solution. Okay. Then the next question I am having here for from the same thing, engineering mathematics, and here this question is from the maximum minima, and this time in the morning, means in the mechanical paper, one question has been asked from the maximum minima of one variable, and here we are having a question from maximum minima of two variable. Let's see, it's talking about ki for the given function fxy equals to, what is this, x square plus x plus y square plus 1. This is the function x square plus x plus y square plus 1. X square plus x plus y square plus 1. This was also the question, x square plus x plus y square plus 1. You guys can confirm, the data which I am having according to this one, this is the function x square plus x y square plus 1. And here also the function x square plus x y square plus 1. Okay? And they are asking will be minimum, it's asking it will be minimum, then it will be minimum at xy. Okay, or I think it is asking it will be minimum, the function is minimum, then xy will be what? The question is given function is minimum, okay, then the value of xy is what? They are asking about ki set has infinite value, whether it is having infinite value xy will be, or it is having finite value, some finite value, or it is talking about such there is no such set exist, or last is cannot determine. Okay, let's see how we can solve it. So function is given to us very easily. I am writing again the function fxy is x square plus x plus y square plus 1. Here I need to find out the p. P means del f by del x. Del f by del x means 2x plus 1. When you are putting it equals to 0, it is giving you x is equals to minus 1 by 2. Okay? And then you need to go for the q del f by del y. Del f by del y is only 2y. When we are putting it 0, it is giving you y equals to 0. So the point xy or the coordinate of xy we are getting here as in minus 1 by 2 or 0. Okay? I don't know whether this minus 1 by 2 and 0 we are having minimum or not, because the question is talking about minimum na. So we need to check the complete condition for the minimum. So when I am checking here p, q, r is double order derivative with respect to x. So double order derivative with respect to x is 2, r is greater than 0. Okay? And s is a double order derivative with respect to x and y, both which is 0 when you will differentiate this one with respect to y or this one with respect to x, result is 0. And the t double order derivative with respect to y, which is again 2 positive. When we are checking here, r is greater than 0 as well, rt minus s square, rt 2 into 2 4 minus 0, that is again positive. So r is greater than 0, rt minus s square is greater than 0, so hence this is a condition of minima. So we are having minima at the given point minus 1 by 2 0. If they are asking point, then the result is minus 1 by 2 0. If they are asking ki whether for the xy we are having a finite value or not, so yes, we are having a finite value, which is the option B. If they are asking finite value, they are asking xy, so result is minus 1 by 2 0. Whatever is the question, but very easily every student can solve. If you attended all the lectures with me, and very easily we can solve these type of questions. Already we discussed in our classroom so many times. Okay? And I think I'm having one more question, which is from the same the algebra. Okay, so this is the question which I'm having from the algebra. This is talking about ki for the given matrix P, which is 2 1 0 minus 1 0 0 or 0 0 1. Okay, for the given matrix, find out the value of P square, and I think some options available for us. P, it's I identity, it's P plus identity, and it's 2P minus identity. 2P minus identity. Okay. So basically it's talking about P square. P square means matrix P is available. We need to go for the product of the matrix, multiplication of the matrix, and we can solve it. So simply we can solve it. Let's go with the P square is P. I'm writing again 2 1 0 minus 1 0 0 or 0 0 1. Multiply with the same 2 1 0 minus 1 0 0 0 0 1. When we are multiplying here, what should be the result? Simply first row we need to multiply with the first column. So 2 into 2 4. Okay, 4 minus 1 plus 0. Next, first row when you are multiplying, this is 2. This is 2 plus 0 or plus 0. First row with the third column 0 0 0. So this is 0 only. Then when I will go with the second row with the first column, so minus 2 0 or 0. This is again minus 1 0 0, and this is to 0 0 0. Okay, and the last is again 0 0 0 0. This will be 0 0 0, and this will be 0 0 or 1. So 0 0 1. Okay. So when we are writing, this is 4 minus 1, basically 3. This is 2 plus 0 is 0. This is minus 1, or this is minus 2. When I'm checking the option, it's not P. Nah, it's not P. P is 2 1 0. It's not identity. Nah, these two options are not at all correct. When I'm going with the P plus identity matrix, P plus identity, when you will add to 2 plus 1, so next element will be 3. It is possible, but I'm not sure. When I will go with this one, minus 1, because when you are adding the identity, na 1 0 0, 0 1 0 or 0 0 1. Okay? When you are adding the identity, so this 2 plus 1 will be 3. The next element is 1. We are having next element as in 2, so which is not possible. So this option is also not possible. So I am sure the remaining one is the answer, but still you can cross check 2P minus I. 2P, when I am going with the 2P, so this is 4. Okay, this is 2, this is minus 2, or this is 2. 2P plus I, no, 2P minus I. So 4 minus 1, 3, 2 minus 0, 2, correct. Minus 2 or minus 0, minus 2, correct. And this is 0 minus 1, minus 1, correct. And the last is 2 minus 1, 1, correct. Absolutely correct. So this is satisfying the result. What is this? This is 2P minus I. 2P minus I. We can check, we can confirm the result as an option D. I don't know about the sequence of the options, but I am talking about the pattern, the result. So these three are not satisfying, so surely this is the correct one. Okay guys, so these are the questions which I got I can say as an memory based questions these are. Okay, once I will have the more questions, surely I will come again with the more questions. So these are the questions. I think the other students also, sorry, the other faculties as well cover the core, the technical subject solution. So dear students, that's it from our side, and all the very best for all those students who are having exam on the 15th and 16th, is EC students, DA students, civil students, all the very best. So just learn from these two papers, okay, on the first and second which type of paper has been asked. Okay, for the EC student you need to understand from the IN, the EE paper, as well the CS paper, which type of question has been asked. The mechanical students, from the mechanical students, civil students can easily understand which type of question has been asked. So you will have a you should have a close observation, and then you will get an idea ki the moral of the story is you need to focus on the PYQs. Okay, if you have a close, means I will say, if you have a close observation on the every PYQ, and here also the pattern is repeated every time, the pattern of gate questions repeats. Okay, you can see this proves in the yesterday and the today all the slots paper. So you need to have enough practice of PYQs, and if it is possible you can go with the one or two at least. If it is possible, I will say now you are having almost the 12-13 days, you can go with the 2-3 mock test as well, the complete full length mock test. So you will have a more idea ki where I am lacking, okay, whether I need to focus on which concept, which subject, which chapter I am lagging behind. All right guys, so stay connected to IIMS Academy YouTube channel. Bye bye, take care, thank you.